Today's topic is slope fields. We know that anti-differentiation in definite integration is the same as solving differential equation. So for example, this derivative dy dx is the same as, we can say, f prime of x is the same as h prime of t. Solving this equation means getting back to either getting y equal to or f of x or h of t. We have already done that. The general solution means we have to write plus c. Particular solution means you find the value of c using initial conditions. Now, many times differential equations are not easy to solve. That means they are not explicit function of a single variable. If you cannot separate the variables, you cannot solve it. And then we have to do the approximation. There are two methods to approximate the solution. One of the method is called slope field, which is a graphical general solution to the differential equation. Now remember, the derivative is nothing but the slopes. Derivative is nothing but the slopes. So when we work with the differential equations, we are dealing with expression that gives derivative. So let's take a look at this example, which is dy dx is equal to x square. If we replace dy dx in above equation with what it represents, we give the following statement: dy dx is nothing but the slope. So we can say that slope at any point is nothing but the x coordinate square. Now consider the example here, following differential equation where dy dx is negative x over 2y. Now before that, I would like to explain where do you use the slope field. So take a look at, I'm just explaining something here. So it is possible to learn a great deal about a differential equation when we don't know how to solve the equation. The slope fields, it looks like this. You can see those pointed arrows. It just shows you the slope at each point. I'm sure you have seen it somewhere, everywhere. This is just called a direction field also. And in a real life, many times we are just using it to predict the flow. Okay, so take a look at this example. Dy dx is equal to negative x over 2y. If we look at the dy dx, which is nothing but the slope. I'm trying to write down here something with my pen, but it's not happening, so I'm going to keep my work here. Okay, so dy dx is negative x over 2y. Question says sketch the slope field to the differential equation on the coordinate plane. So all you have to say is, this is the slope equation, and when x equal to 0, slope is 0. So all you have to do is show the tiny line. This is the slope 0. That's the slope 0. That's the... So let me try again here. I'm trying to use the pen. So that's the slope 0. Slope 0. Now 0 over 0 is not defined, so that's why we don't do anything here. On y coordinate, slope is a 0. When y equal to 0, slope is undefined. So what you have to do, it is all the y is 0. You can see the vertical line, tiny vertical line you are sketching to show that the slope is undefined. Now all other places, you are just approximating the slope. For example, x is a 1 and y is a 1. So negative 1 at this point. At this point, x is a 1, y is a 1. So slope is negative 1 over 2. And you can show the tiny, like a negative slope, but little horizontal line. Here would be x is a 1, y is a 2. So the slope is negative 1. And 2 times 2 is a 4th. So more horizontal line. And like that, you just count everywhere. Like for example, here, what's the slope? X is a 1, y is negative 2. So what that slope becomes is negative 1 over 2 times -2. So that makes positive slope. And you show that the slope is positive. And you sketch all those slopes, and that is called slope field. Now, when it says sketch the possible solution curve with this point 0, 1, and that's where you have to start with. You start with here 0, 1, and you just have to follow the line. Just follow the line. You just follow the line. I'm trying to sketch the graph. Start with here 0 slope, and that, so you just try to sketch the solution curve. This is your solution curve, which is on this solution to this differential equation. Now let's check whether we can solve this equation, whether we can separate the differential equation. So it is not possible to separate the differential equation because you need dy dx, I'm explaining here. Dy over dx is equal to -x over 2y. Now x dx, you can take this side, and the 2y dy, this is called separating the solutions, which we are going to look at in the next lesson, but we are not required to solve at this time. Let's take a look at another example. Okay, so many times slope field questions are always matching. Shown to the right is a slope field for which of the following differential equations. So now you have to analyze the slope field here. You can clearly see that this is the line. Okay, so let's check the slope here. You can see that here the line is when x, -x plus y, this is a 1, 1. So look at this slope, and we can say that -x plus y is equal to 1. Then you can see that second quadrant slope is positive. You can say that whenever the -x, slope is always positive. You can see that all this slope is positive, only this side is the slope negative. Now in a fourth quadrant also, you can see slope is almost undefined. So this line shows x equal to y. Oh, another one, we have to notice this one. Do you notice that? That's the 0 slope. So we can say x is equal to y, slope is 0. That is very helpful information. So x equal to y, slope is 0, not this. This is possible. X equal to y, slope is 0, that's a possible. X square minus y, that makes slope is always positive. But then this doesn't really help. So then you have to look at this and pick any point and check it out. Which one gives you the 0 slope? So typically pick the second quadrant. You can pick the second quadrant, -4. X is -4. Y is +2. -4, +2. That doesn't work. So that gives you negative slope. So X has to be multiple choice. Answer is a C. Let's practice some more on another example here on this page. Graph to the right shows the slope field for the function f of x. The initial condition is 0, 6. What is the range of the solution curve for this? So let's take a look at this graph carefully. You can see that the slope is 0. Can you see here also that the slope is equal to 0? So in other words, this is a logistic function, and you sketch the graph and you can just follow the guideline. Just follow the line where the graph is going. If you follow, then this is also the graph goes like this. But here the question is the point has to pass through 0, 6. So 0, 6 is here. Point is a 0, 6. So sketch the solution curve, go through the 0, 6 like this. So what is the range? The range is horizontal asymptote at 4. So 4 is not included, and 6. This is the range. You can also write it as, negative 4. 4 to 0. Let me bring my answer. I'm having hard time to write it down. So you have to consider the initial condition. Now, if my initial condition is, this is, I'm just writing the another option. If my initial condition is 0, 1, then what will be the range? Then you can say the range is between 0 and 4. That will be the range. Let's take a look at one more example. I'm having a hard time to write down on this. So what is the general solution to the differential equation that generated the slope to the right? Now clearly you can see that this graph has up and down, and you can see that this is a trig graph. Just follow the path and you can see that the graph 0, then goes up, then the slope is 0, then comes down, the slope is 0. So which is the general solution? So you are trying to find the graph, what graph it resembles. Try to sketch the line anywhere. You can see the C is any constant, and you can see that does it look like negative cosine, positive cosine, cosine, negative sine, or sine. And based on this, you can see this is the sine graph, and pick any point. Let's check this one. Check this one. Anywhere. C could be any value. C could be any value. Try to sketch the graph. See, they are all sine graphs, so answer is E. Okay, let's take a look at one more example here. Consider the differential equation dy dx is x square times y minus 1. Describe all the points on the xy plane for which the slopes are positive. Let me explain one more time. Slopes are positive. So positive slope means x square is always positive. When this factor will be 0, when positive, when y minus 1 is greater than 0, which means y has to be greater than 1. So it says describe all the points. So all you can say that slope will be positive. Slopes will be positive when slopes will be positive if y is greater than 1. Bring my answers back. Slope will be always positive if y is greater than 1. That's all you have to write down. Okay, so let's take a look at different type of examples where you have to do something different, multiple choice question. Okay, which of the following differential equations, the slope will shows nothing but negative slopes in a fourth quadrant. Negative slopes in a fourth quadrant. So you have to know that, sorry for technical difficulty, negative slope in a fourth quadrant. So let's check the fourth quadrant. Fourth quadrant, x is positive, y negative, and you are looking for negative slope. So let's check here. 2 negative, x is always positive and y is always negative. This will give me positive slope. That's not x and y plus 5. So this combination is always negative, but depending on the number, if you add 5, that could be possibly positive. So that cannot be. Here x and y square, negative number you are squaring become positive, x is positive. So positive number and you are subtracting 2. We don't know whether that's a positive or negative. Okay, so here let's check the D. Y square, again you are squaring the negative number. X cube is always positive, so this is always positive. Now the left is last choice. Let's talk about here. This is very good example. X square So positive number, your square is positive, y is always negative, and you are subtracting 3 will always be negative. That means the best answer choice is a E. Again, one more time, let's check again. I'm clearing. This is the answer choice because that's a negative. This is positive and you are subtracting 3. So this will always negative slope. Fourth quadrant, remember fourth quadrant, again x is always positive, y is always negative. Let's take a look at one more example here. This is another very good multiple choice question. It says, which of the following differential equation would produce the slope field shown below? Okay, so here you have to understand the absolute value. X is always positive, y always positive, final answer is positive, which is never true. You can see that all these slopes are negative, right? These are all negative slopes. So never this. Same answer here, always positive, which is not true because you can see that all these slopes are negative. This tells you that slope is positive, negative, but they are always. So now let's take a look at carefully where we can see the slope is a 0. So check this line. Always look for the horizontal lines where slope is a 0. So when do you get a 0 slope? Now let's talk about here. X is positive. So in the second quadrant, X is positive, negative X but becomes positive, and the Y is also positive. So both two numbers are same. Slope is a 0. When X and Y is the same, slope is a 0. So we can say that 0 slope when X and Y are almost same. You can see that X and Y are same. So that will be the answer is here where the slope is a 0. These two C and D always produce positive slope, which is not the case. These are all the negative slope. We can consider A and B are better choice, but the B has clearly you can see that the X is this negative X becomes positive and that will not give you a 0 slope. So the answer is A. And the last one on this example, very similar one. Which of the following differential equation will produce the slope field shown below? Okay, so here I'm searching that these are all the negative slope. This is negative slope. This is also negative slope. Here you can see all those lines are pointing up, so that slope is positive. That's the same scenario, slope is positive. And all you have to pick a point and check where do you get the positive slope. So pick any number here and you can substitute and check the answers. In this case, the answer is a E. Why not? Here you can see that these are the positive slopes, X and Y both positive, so this will be fine. This will be fine, but you have to always look for the counter example. 2 negative makes it positive, but then you are subtracting and then divide by 3. So the best scenario you have to pick is pick any point and check where do you get the 0 slope on the horizontal axis and bar. So in this case, the answer is a E. Now, if you need more explanation, I can write that here. If X is greater than 0, slope is greater than 0. If X is less than 0, slope is less than 0. And pick point and check. That's how you have to answer. So slope field questions are always going to be multiple choice question. And the best choice is elimination. Eliminate always certain choice. This cannot be the answer. This cannot be the answer. And out of certain numbers left, pick a point and check quadrant by quadrant. Now I will explain here. The goal for student is to be able to do the following with the slope field. Sketch the slope field. Rarely it is asked in APBC calculus exam. Most of the time